Hello again, Tom from Every Step Physics, everystepcalculus.com. This is a physics problem from a test, and I'm going to show you how my programs work on this. This problem is finding the time that the mass or object stops revolving. Okay. And as a heads up, the mass here is not involved in the calculation, so you can throw that out. So keep that in mind. And they throw it in here for confuse you, I suppose. Whatever they do here, whoever writes these problems. And the main thing about this problem is that you're going to convert 20.5 RPMs to rads per second. Okay. And angular speed is really the Greek alphabet letter of omega, which is a W, kind of a cursive W. So let's do this problem. Physics to get to my main menu. I'm already at angular acceleration. And we're going to find what the variables are here. We have revolutions, and we have mass, and we have the Greek letter cursive A, which is angular acceleration. And since we don't see it here, this is all alphabetical. This is linear acceleration here. It's not like angular acceleration. So let's we have to press second. Don't have to. You can scroll down item by item, but I like to go, and I don't see it here, I like to go page by page, which pressing second first does. I don't see it here either. We're looking for, here's time object stops. I'm going to use this to go up to it and press enter. I instruct you a little bit, mass is not involved, and that we need to change the RPMs to rads. We enter the variables, and we have to press alpha first before we enter any variables in here. We're going to put the 2 kilograms in here, even though it's not used in the calculation, simply because I don't want to confuse anybody who's looking at these programs. It's here, so let's put it in there, okay? Alpha 2. I do the calculations for you. Everything is kilograms in these formulas and equations. And then we're going to press alpha to put the angular acceleration in, or alpha minus 2.68. And we're going to enter the revolutions. Alpha 0.5. I have to go slow, otherwise the simulator might screw up. And it's RPMs, and we want to convert it to radians per second, so we choose that. And we've done it. Here's omega. The initial angular velocity is omega 1, and that's 2.1468 rads per second, okay? I show you what you've entered. Here's 2 kilograms for the mass. Here's the angular acceleration of minus 2.68, and then the angular velocity, 2.15 rads per second. I say it's okay. Could have changed it if you messed up or something. I always give you that option. Here's the formula. T equals time to stop equals the final velocity, angular velocity, minus the initial angular velocity divided by the minus angular acceleration, which they have here. And those calculations turn out to be minus, 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 and then we do the calculation. It turns out to be 0.80103 seconds for it to stop. Pretty neat, huh? EveryStepCalculus.com. Go to my site, buy my programs, you'll pass physics or you'll pass calculus. Simple as that. Otherwise, you've got to take enormous amounts of time to memorize this stuff and be able to take the test and do your homework and ignoring other things you might study that might be more important for your major. But anyways, subscribe to my site if you want to, and share this or send it along to somebody else, you know. Maybe you can help them too. And in the meantime, have a good one. Good luck in your classes.